in this session. So we'll do a quick revision on latches and flip-flops and do few past paper questions. Okay. Right. So we have completed combinational circuit components. Combinational circuit components means your output depends only on inputs, right? So there's no other thing. For a given input at any time, the output is determined by the circuit, nothing else. So the second type of circuits are sequential digital circuit components of circuits. Okay. So here combinational output depends on input, whether it's T1, T2, or T3. But now you can see in sequential circuit components, the output depends on both input and output at the previous time, because output is fed as an input. So these kind of circuits are called sequential circuits. Okay, so understanding these circuits are a little bit more challenging because you need to think as a sequence of time. Right? So you can't just look at a snapshot or picture and determine what is the output by analyzing the circuit. So you need to do it by analyzing the circuit for few clock cycles. Okay, so that is what sequential circuit components are, and that is what made understanding sequential components a little bit more challenging. Okay, and these sequential circuit components are very important for memory cells, counters, and so on. Okay, so now you can see this is a sequential circuit component because one of the output is also fed as input. So now you can see for the same input combination, there's a possibility of different output. So here out 0 0 input combination output is 1 0. 0 0 input combination now output is 0 1. So this is possible in sequential circuits because there's a third input which is the output of the previous one. Okay, previous time. Right, so that is called sequential circuits. So these are the sequential circuit components. You can have latches, flip-flops, shift registers, counters. Okay, so those are all sequential circuit components. We will be only looking at latches and flip-flops. We are not going to look at shift registers or counters, but just remember those are also sequential circuit components. So we can subdivide sequential circuit components into two. That is sequential circuit that does not depends on the clock signal. Those are basically latches. Sequential circuit components that depends on the clock signal. Those are pretty much flip-flops and counters. First, we will look at latches. Those are relatively easy to understand because it does not depend on the clock signal. But anyway, the output is fed as input. So therefore, those are sequential. Then we will move on to sequential circuits that depends on the clock signal. Uh, those are flip-flops and counters, but we will only look at the flip-flops. Right. Latches. Okay. So the word latch literally means something like this kind of a lock. So we can lock it, and until we unlock it, it stays in the lock state. Then we can unlock it, then until we lock it, it stays in the unlock state. Right? So that is what we want to do in memory cells. We must be able to set it to 1 and stay in the one position until we reset it to 0. Then it must stay in 0 state until we set it. So this is called set. This is called reset. And staying in the same state is called memory or latch. So we set it to 1 and let it latch or memory to 1. We reset to 0 and let it stay in 0, or we say memory latch to 0. Okay. So that is the purpose of latches. Okay. At any time, if you have any question, even a slightest doubt, you need to ask. This is the hardest topic in your computer system subject. Okay, hardest topic to understand. This is the topic where you get the hardest questions. Right. So we will look at three type of latches. Of course, these three type, though we call it three type of latches, these latches are interrelated. So basically, once you understand SR latch, you can self-understand S bar, bar latch, and D latch. So therefore, your first task is understand SR latch. Then from that, you can understand the other two. Okay. So let's start with SR latch. So SR latch stand for set reset latch. S set, R reset. So that means it's a latch or memory cell that we can set and also we can reset. And of course, in between, it can remember or latch or memory state. So this is the simple SR latch circuit. It's very simple. You just need two NOR gates. Okay, you just need two NOR gates uh, and two inputs and two outputs. So usually we call this reset R out input, set or S input. These are called Q and Q bar. So when this is 1, this must be 0. When this is 0, this must be 1. That is our expectation. So therefore, rather than two outputs like O1, O2, we can say Q and Q bar. Okay. Always, this output must be the negation of this one. If not, it's an invalid state. Okay. And remember, your Q side, you have R, not this. So you must pay attention to these small things. At R and Q is in one NOR gate. Q bar is connected to S NOR gate, the S input. And also there's a feedback loop. So the output of the first NOR gate is the input to the second gate. Output of the second NOR gate is the input to the first NOR gate. One of the input. Okay. I will explain how it works. First, you need to understand what is SR latches. So these are the possible inputs. S0 R1, you call it reset because R is 1. So reset means Q becomes 0, Q bar become 1. Okay. So then if you want to retain that, make it both 0. Now earlier we make it S0 R1. Now if you want to retain this after resetting, you make it 0, 0, and still it should remain as 0 and 1. 0 and 1. Okay. And if you want to set it, right, if you want to set it, make S1 R0. That is means set. So then Q will be 1, Q bar will be 0. Now if you want to retain it to latch or memory, again make it 0, 0. Still this will remain the same. As long as it is 0, 0, this remain the same. Okay, so that is how you set an latch for memory and reset an memory. But you must not give 1-1 combination for SR latch. If you give 1-1 combination, it get into an invalid state. So what is mean by invalid state? So the expectation is whatever the value here must be the negation of this value. But when you give 1-1 state, you will get the same output value here. So therefore we say that that is the invalid state for SR latch. Okay. So R1 S0 is reset. Reset means Q bar is 1, Q is 0. S1 R0 is set. That means Q1 Q bar 0. 0, 0 means whatever the previous state is retained. 1, 1 must not be given because it will lead to an invalid situation. Both Q and Q bar get the same value. So if someone asks you to explain SR latch, its behavior. So this is the behavior. Okay, this is the behavior. Right. So the next thing is, now you know that we can use SR latch as a memory cell because we can set it to 1, let it remain there, reset it to 0, let it remain there, but make sure you don't give 1-1 combination. Okay. So this is the summary. Right. S1 R0 means you set it. R1 S0 means you reset it. So Q is 0 now. 0 means whatever the previous value is retained. If previous 1-0, it retain 1-0. If previous 0-1, it retains 0. If you give 1-1, it leads to invalid scenario because both will be 0. Okay. So those are the 4 situations. Right. So now let's understand how this work. Okay. How this SR latch set memory, reset memory, and why it is invalid 1-1 is. Right. How to set and remember? Give S equal 1, R equal 0. To retain it, make both 0 after doing this sequentially. Okay. Right. So let's see what happens when we give S equal 1, R equal 0. S equal 1, R equal 0. To understand this, you need to understand or remember the truth table of NOR gates because these are 2 NOR gates. This is the truth table of NOR gate, not the truth table of this latch. You know that in NOR gates, right? When both are 0, it is 1 because 0 plus 0 is 0, 0 bar is 1. In all the other cases, it is 0 because when at least 1 is 1, output is 1, then negate, it becomes 0 because this is not OR gate, this is NOR gate. And clearly you can see that when at least one input is 1, output is 0. We don't care about the other one. When this is 1, this is 0. When this is 1, this is 0. When both are 1 only, also it is 0. So that means at least 1 is 1 means we don't care whether this is 0 or 1, this is output is 0. But you can't say something like that when first input is 0 because when first input is 0, if the second one is 0, it is 1. When first input is 0, if the second one is 1, it is 0. So therefore, if we know that one of the input is 1, definitely output is 0. But if one of the input is 0, no, we can't say exactly what happens unless you know what is the next one. What is the other input? Okay. Right. So that is the tactic we use to understand this and design this. Okay. That is why this statement is highlighted everywhere because using this statement, you understand this. In an OR gate, when at least one input value is 1, regardless of the other input, the output is 0. Using this statement, you can understand this SR latch. Right. So now the situation is set. Okay. Situation is set. That is S is 1, R is 0. And remember, when at least one input is 1, the output is 0. So therefore, this output is definitely 0. But you don't know what is this output is because when this is 0, depending on this value, this can be 1 or 0. So therefore, for this particular clock cycle, I'm not sure what is going to be the output because until I know this input, I can't say what is this. But in the next clock cycle, I know that because this is 1, the output is 0. So therefore, this 0 is fed it here. From next clock cycle, both are 0. Both are 0 means output is 1. And that one will be fed it here for the next cycle, third cycle. And when both are 1, it's 0. And this 0 is fed it here. And both are 0 means 1. That one is fed it here. Both are 1 means 0. You can see that it stays Q1, Q bar 0. So that means when R equals 0, S equal 1, you set it because this stays 1 and this stays 0. So that is why we say R equals 0, S equal 1 means setting the latch or setting the memory cell. Okay. So if you want, you can just use, suppose if you have SR latch as electronic component and breadboard and battery power and LEDs, you can do it practically. Or else you can just try, say, logically. Try online. Let's drag and drop two NOR gates. Two NOR gates are required. Okay. So this output is connect to here. This output is connect to here. I need toggle switches. And to check the output, I need bulbs. Let's add some labels. So this is my R. This is my S. This is my Q. And this is my Q dash. Right. So now what happens when we set it? S1 R0. Then Q must be 1, Q dash must be 0. You can see. If you keep this state forever, Q is 1, Q dash is 0. Okay. So that is how you set it. Now, the idea of SR latch is not to keep this state forever. Rather, now if I make it both 0 again, that means again make S0, it remain that state. So that is what is meant by memory. So that is why we say you set it and then you make both 0, still it remains in that state. So that is what is meant by set and memory. Set and memory. Set and retain it. So now you need to understand when we make it both 0 again after setting, why it remains there. You need to understand this is formal science. Okay, computer science, computer systems, you should understand 100%. Don't settle for 90% and think that okay, you can't do it more than that. Apply that for chemistry, physics, and biology, not for computer science. Either you understand 100% or you don't understand. Okay, you forget about your computer science system, science subject then. Okay, right. So now let's see what happens when you make it back to 0, 0. Now we have already set it. Right? We have set it. So this is the final state. This is 1, this is 0. Now we want to make, while it is in this state, that means Q is 1, Q dash is 0. Remember Q is 1, Q dash is 0. Now we have make both 0. That is, while it is in the set state, we have put it back to both 0. Now what happens? Remember when at least one input is 0, sorry, when at least one input is 1, output is 0. Right? Remember, this is previously 0. So therefore, this is 0. And this one is from previous clock cycle. Before we make it 0, previously it was 1. So therefore, in the next clock cycle, this is 1, this is 0. Now again, we have one of the input 1 here. So therefore, in the next clock cycle, for this NOR gate, it is going to be 0. Because when at least one input is 1, which is the case because the previous it was 1, now the output is again going to be 0. And this 0 is going to be fed it to here. And of course, these are zeros. 0, 0 is 1. So therefore, again, it's 1. This one is fed it here. When at least one input is 1, it is 0. That 0 is fed it here. When both are 0, it is 1. And you can see that still it stays in the same thing. So now we have make it both 0. Still, because we start with 1, 0, this stays the same. So that is why it's retain the set value. So you need to understand your thinking start. Previously we have set it, therefore this is 1, this is 0. Right now we make it 0. But for the next clock cycle, this output is fed it here, this output is fed it here. When it at least 1 is 1, output is 0. When both are 0, output is 1. That 1 is again fed it here. 1, 0 is 0. 0 is fed it here. 0, 0 is 1, and so on. You need to think sequentially. That is why we say sequential. And you can see that, yes, it retains. It retains. So you set it, and still it retains. Okay. Even when you make both 0, it's retained. So that is how set and memory work. So similarly, if you want to reset, you make R1 is 0. Then Q will be 0, Q dash will be 1. And as long as it is in this state, it will be there, but we can retain this even by making both 0. That is reset and memory. So you need to understand yourself, explain yourself that how it works. Because otherwise you are just blindly memorizing things like a dumb person. You don't need to be a dumb person, right? So the IT is not for dumb people. IT is for smart people, intelligent people, curious people, right? Critical thinkers, logical thinkers. Right. Now let's see how to reset. Okay, this is how it remember. So reset means R1 is 0 and then make both S and R 0. So let's make R1 S 0. Again, when at least one input is 1, output is 0. So therefore, this is 0. From next clock cycle, this is 0. Both 0 means this is 1. 1 is fed it here. Both 1 means anyway 0. That 0 is fed it here. Both 0 means 1. That 1 is fed it here. But we don't wait until these things happen forever. We just wait for one clock cycle. That is good enough to make it 1 and this is 0. Then immediately we make both 0. But by the time we make it both 0, this is 1, this is 0. Now let's see what happens when we make, because we immediately make it both 0, okay? So by the time we make both 0, this is 1, this is 0, okay? Right. By the time we make it 0, this is 1, this is 0. Now you start thinking from that point because we have reset it. Now we make it 0. So therefore for the next clock cycle, this is 1, this is 0. When at least one input is 1, output is 0. So therefore this is 0. When both are 0, it is 1. This one is fed it here. When at least one input is 1, output is 0. When both are 0, it is 1. So therefore now, even though you make it both 0, it stays in the same thing. Actually, this stays long time because this is my memory state. Until you set it again, this stays 0, 0, and this keep happening in each clock cycle. But it doesn't change the value. Right. So that is how SR latch work. Set and remember. This is reset and remember. But there's an invalid scenario. What is that invalid scenario? 1, 1. If you ever give 1, 1 to the SR latch, right? Assume we give 1, 1. Now you know that when at least one input is 1, output is 0. So therefore now this is 1 means output is 0. This 1 means output is 0. That 0 is fed it here. That 0 is fed it here. But again, when at least one input is 1, output is 0. Output is 0. That 0 is fed it here. Now this keep remains both 0 forever as long as you keep it 1. But that is not the expectation. When this is 0, this must be 1. When this is 1, this must be 0, but this is both are 0. So therefore we say S equal 1, R equal 1 is invalid scenario in SR latch. Okay. Right. Now can you proudly say that yes, I know how the SR latch work? Okay. I know how SR latch work. I'm confident about my SR latch. Okay. Or do you have any questions? So if you have any questions, doubts about SR latch, because there was some chat question saying that a lot of doubts about SR latch and blah blah blah. So now, still, do you have those doubts about SR latch? Right. So do this question. This is a A-level question actually. So these are not hard things. Even A-level ICT students in schools do this. How can you say that these are difficult? Then you must be childish. Right. Quickly do this. Anyway, this is a textbook question. Okay. They say flip flop, but actually this is not a flip flop. So in A level ICT, they teach latches saying that those are flip flops. Okay. Of course, A level ICT students, we can little bit fool them. Of course, I don't fool them, but some teachers fool them. Okay. Saying that these are flip flops, but actually these are not flip flops, these are latches. What is our answer? This is a paper 2 question, 2023, last year paper. Paper 2 question 8C. Take your time and do. This is super simple, right? Just check whether you know truth table. So this is a textbook question, right? Anyone should be able to write this. Even a fool can write this by memorizing without knowing how it works. So those guys also can pass the exams. That is how the foolish people also get degrees, okay? Because there are loopholes. Right. Assuming that the S input is 1 and the R input is 0, what will be the output of Q? So that means set. So output of Q is 1. And of course, Q bar will be 0. Second one, what will be the output at Q if the S input is now made 0? Now made 0. Now you make it 0. So by the time your Q is 1, Q dash is 0. Now it is memory. It retained the previous value. So therefore still Q is 1. Okay, because it says uh, now made 0. That is after this. That means previous state is now retained. Third one, what will be the output at Q when the R input is now made 1? Now you make 1. Now, by the time both are 0, now make this 1. That means R1 is 0 scenario. That is reset scenario. So when you do that, this will become 0, this will become 1. So therefore now Q is 0. So answers are 1, 1 and 0. Okay. Answers are 1, 1 and 0. Yes, correct answers are 1, 1 and 0. So you should do this with a lot of guts, confidence. So those are the guys who go for interviews, go anywhere in the world and live happily. Never do BIT to get a certificate and right. Right. Now we'll move on to our next variation of SR latch. And this is called gated SR latch. Okay, gated SR latch. And this is the circuit. So you can see there's an additional part here. Earlier our circuit is this. This is basically SR latch. Now we have provide additional gate. So this is our gate actually. So this gate is, of course, this is a logic gate. But this component is, we call a gate. And so this part. Okay. This is our additional support for the SR latch. Additional support to additional guard. Gates are for guarding things. And here you can see we have another input called enable. And this is your good old R. So remember R used to be here, S used to be here, Q and Q bar. But now your R is, actually this is your R, old R, but now it's has an AND gate which has R and E and together and give it as your new R. Sometimes we call it R star now because this is our input R. And similarly, this is your old S, so we'll call it S star. That is your S star is S and enable. S and enable. And this is another input. It can be 1 or 0. Okay. Of course, R can be 1 or 0, S can be 1 or 0. Now we have 3 inputs now. SR and enable. SR and enable. Okay. Now when enable is 1, right? When enable is 1, this truth table is same as previous. Right? Previous means when S is 1, R is 0 set. When S is 0, R is 1 reset. When both are 0, memory. Previous value is remembered. When both are 1, invalid. So therefore, when enable is 1, this is good old SR latch. Okay. But when enable is 0, it again gives you opportunity to memory. So now we have two approaches to give it to the memory state. Either enable is 1 and make both 0, or just make enable 0. When enable 0, it is memory. So now we have two ways to get into the memory. Okay. While enable is 1, make SNR 0, or just make enable 0, then regardless of your SR values, whether it's 1, 1, 1, 0, 0, 1, 0, 0, this is going to be whatever the previous value is written. Okay. So that is called gated SR latch. So then someone will ask why? How do you get into this kind of truth table? Because this is not coming from heaven. Okay. Right. So the idea is this. When enable is 0, you know that in this AND gate, when at least one input is 0, output is 0. So therefore, both R and S0 means memory. So therefore, when enable is 0, obviously it is memory because when enable is 0, both S star and R star is 0. So therefore, that explains this. Okay. So then when enable is 1, how does this behave in the good old way? That is also self-explanatory. When enable is 1, this is R dot 1 is R. Remember R dot A dot 1 is A. When enable is 1, R dot 1 is R. S dot 1 is, when enable is 1, S dot 1 is S. So therefore, when enable is 1, this R is this R. This S is this S. So therefore, obviously, it must behave in the old way. Okay. Because this input is not changed, same input you are getting. But when enable is 0, we are getting 0, 0 situation. So therefore, when enable is 0, it doesn't matter whether this is both 1 or 1, 0 or 0, 1 or 0, 0. It's always 0, 0. So that is why always memory. So that is, so this, then someone will ask, what is the advantage of this? Why do we need two ways to make it memory? So the one advantage is there can be stray signals. Stray signals can කාට මොනවාද? Stray කියන්නේ stray dogs කියන්නේ දඩාවත යන බල්ලන්ට. Right? Stray cows දඩාවත යන හරක්. Stray signals because these are circuits. There can be all of a sudden stray pulses. So you want to make it, you have made it 0, but all of a sudden there's a small pulse here because of some issue. So if that happens, all of a sudden this can change. All of a sudden your set becomes reset or get into invalid state. Right? So therefore, we want to make sure Now earlier we rely on S equals 0, R equals 0 for memory. But there's a possibility of stray signals coming here. That signal pulses එකපාරට එන්න පුළුවන්. So then all of a sudden memory අවුල් යනවා. 1 කියලා හිතන් හිටිය එකන එකපාරට 0 වෙනවා නැත්නම් invalid වෙනවා. So in order to prevent that, we can use this signal. Okay, because when you want to get into memory, forget about R equal 0, S equal 0, rather make enable 0. Because when enable 0, it is memory. And we can isolate this enable signal from other signals. Because other signals are interconnected from other outputs. But we can make enable isolated signal so that it has lesser chance of stray signals. So that is why this circuit is better than the Pro SR latch, because this has a gate. It has additional defense against stray signals. Okay, because this signal can be isolated from, because these are mostly output from another circuit, but this can be from freshly from source. Right? Any questions about gated SR latch? So you must have answers: what, why, how. So if you don't have answers for all three, you have not understood it, or you just like a parrot memorizing things. You're not going to make any progress in your life career because you lack confidence. Okay. So the idea is get an additional guard against stray pulses for S and R signals. Because enable can do that. Memory, whether it's memory or not is determined by enable is 0 now. Okay. Because A.1 is A. When enable is 1, it behaves pretty much like the old way. R star is R, S star is S. But when enable is 0, both are becoming zeros. So therefore it is basically memory state. But we get into the memory state by making enable 0 this time, rather than making R0 S0. Of course, R0 S0 is also memory, but we don't rely on that. Okay. So we can create this circuit also, because we already have the SR latch. Just we need to AND gates and additional input. This is my R star. This is my S star. Whatever, okay. New S. Right. Now when enable is enable, this behaves like any other normal SR latch. So if I want to set it and memory. If I want to reset it and memory. But remember, we don't rely on this situation for memory. What we do is we set it, okay, and make enable 0. Now it is memory. Now, even though when you change these things, that is stray signals, right? You can see still it is memory, right? So it doesn't respond to abrupt changes in your RNS. Okay. Now I took it into the I just put it into the original set state. Now I enable it. After enable only, you need to do the set or reset. Now I want to make reset. Then I again make disable. Now it is again not responding to these stray signals. So these stray signals are the biggest issue. That is why we don't like latches. Rather, we go for the flip-flops. So then someone will ask, why are you so worried about these stray signals? Of course, we are worried. That is why latches are not good enough. We go for the flip-flops. Okay. Right. So that is how you understand it. Okay. Right, do this as exercise. So this is SR latch with enable. Draw the output Q output here. Your task is draw output here. I'll give you 2 minutes because you need to draw this. Okay. Okay. You need to draw this one, then this one, and this enable is always one. Then your task is complete this one. Okay, complete this one. Or if of course if you are using a laptop, you can draw it in the screen, but make sure you draw it in your screen, right? So there's option whether to you draw your screen or shared screen. If you are using a laptop, you can even draw it in your screen and double check whether is it correct. Okay. Because latches are responding to the stray signals. So that means why the latch is enabled. I don't know whether what you mean by latch with enable. Of course, you can see that the latches are not good enough because latches can get into the stray signals for S and R values. But then your question should be maybe why don't we use latches with enable, or why latches with enable are not good enough? Okay. Uh, so that is again a good question. For that, I will give you an answer when we do the flip-flops, because we need to make sure that our latches respond to a very small tiny period only. So that is why we have edge triggering. Even level triggering is not good enough because that is too long time. Okay. So that is why we are going for the flip-flops, and we go for edge triggering flip-flops where the very tiny time period it responds. Okay. So anyway, don't think about that right now because we'll get back to that later. Okay. So basically we want to make sure that our latch flip-flops respond at a very tiny time period, not all the time. Right. So draw the output. Now here enable is always one. Sometimes you feel like I have understood. You have understood, but in reality you have not understood because your brain sometimes cheat you. Because when you feel like you have understood, you don't have to think again. If your brain is lazy, your brain will say yes, you have understood, but in reality you have not understood. That is because brain cheating you. Don't get into that trap. So how do you double check whether you have understood? Do this kind of exercise and see. If you can't do this exercise, no, you haven't understood. Simple as that. So you can't cheat yourself. Okay, right. So what is the output? So output depends on what is the current starting output. Okay. Now this is S0 R0. So let's assume current Q is 1. So therefore I'll start with 1 and assume that it is memory. And enable is 1 means throughout this, actually enable has no role to play. This is basically normal SR latch now because enable is always 1. I will assume that currently it's 1. So therefore Q is 1. Now S become 1, right? R is still 0. By the way, anyway, S become 1 means set. So therefore still it is 1. So now at this point, again S is 0, R is 0. That means memory, right? Until this point. So memory means it retains the same value, right? It retains the same value. Now again S become 1. We don't care, right? S become 1 means again set, but anyway it is already set. So now again is 0 R 0. Remember. Now R become 1. That means reset. And S is 0. That means now it is reset to 0. Now both become 0. That is memory. By the time it is 0, so therefore it remains 0. Now again set S become 1. R 0 means set it. Now again it's set. Now again both 0. That means up to this point, both 0 means whatever the current value is remain. Now again R become 1. R become 1, S becomes S0 is reset. Reset. And both 0 means memory. Now again R become 1, anyway it is reset. And again both 0 means memory. So this is my output. So because enable is 1, this is basically a simple SR latch because it's always 1. Okay, always 1. That is output. Okay. Right. So this one has started with 0. That is okay. Maybe the question, this particular diagram has assumed that initially 0. Don't worry. That is not a big issue. Okay. So I just assume that it is 1. I told you that either you need to assume that initially 1 or 0. So this diagram has assumed that initially it is 0. That is why this small portion. But from this point onwards, only we can definitely say what is the value. Or your question should have told you that current value is what? Because the current value is not given. So I just took it as 1. This answer has to be as 0. But anyway, it's start responding from this point. Okay. Right. Any questions? Now do this. Now this is challenging because now enable is also going up and down. So remember when enable is 0, it's always memory. When enable is 1 only, it behaves like a normal SR latch. When enable is 0, it's always memory. Now draw the output. You can think that, start that your initial Q is 0. Right? Initial Q is 0. Right? Take 2 minutes. Now you need to gradually build your confidence, right? You can't straight away go into the JK flip-flop. That doesn't work. Of course, that work for parrots who want to memorize without understanding, who think only about exams. Okay? So time is enough if you have got it. Let's assume that Q is initially 0, okay? Until this point, Q is 0. Q is 0. Now S become 1, but enable is 0. Enable is 0 means memory. So therefore, until this point, whatever the current value can't be changed. I assume that initial Q is 0, okay? If the answer assume that initial Q is 1, it will be staying at 1. Okay. Right. So now only enable 1. So now your latch is going to work as a normal latch, SR latch. But anyway, both are 0 until this point. So therefore, it will remain in the memory state. Now enable is enable and your S become 1. So therefore, it goes to 1 state. 1 state. And then both become 0. Anyway, both become 0 means still memory. Still memory because 0, 0 is memory. Now enable is 1. Now your R become 1. R become 1, S becomes 0. S is 0 means reset. Again reset. Right? Until this point. Now after this, both are 0, enable is 1, that means it's still memory. Still memory. Reset value. Right, reset value. Now, of course, it goes into the disable state. Disable state means anyway memory. So therefore, during the disable state, it doesn't respond to this because both inputs are 0. Now anyway, now it's again become enable, but no changes to S and R, both are 0. It will remain there. Now again set because enable. It stays like this, and then both become 0. Still it stays like this because it's memory there. Now again disable, it will stay like that for. Okay, that is my out. Because now it's back to the memory, therefore it doesn't respond to this. So I assume that initially 0, right? If initially 1, this will be going like that, but I assume that initially 0. Yes, initially 0. That is the assumption in this answer also. You can see that answer and my answer is compatible. Okay. Right. Any question about SR latch, gated SR latch? Okay. So D latch is a variation of SR latch. So therefore, it's very easy to understand. Now we can go faster. Right. So remember in SR latch, we have two inputs. Two inputs. S input, R input. And also, when you look at the truth table, we can see set is S1, R0. Reset is R1, S0. So that means you swap the two things. R become S, S become R. So therefore, what we can do is, rather than having two inputs, we can use one input. And one, that input is directly connected to S. And to the other one, we just negate and take it to the R. Okay. So then when D is 1, SC is 1, R is 0. That means set. Right? And when D is, we just call it D now, or data. When D is 0, now SC is 0, R is 1 because not 0 is 1. So now we have again, we can set it or reset it. So set means D is 1, that is S1, R0. Reset is D is 0, then R1, S0. Okay. And those are the two things we can do with D. Either make it 1 or 0. Okay. But there's a disadvantage. That is, now where is memory state? Because earlier when we make 0, 0, our value remains the previous one. But there's no such option now because you can't, there's no way you can make both 0 now. That is a disadvantage. But there's advantage also, that is you will never ever go into both one scenario because there's no way you can give both one when you have the same input as it is and not. Okay. So bit of advantage, bit of a disadvantage. But because usually once we set it, we just want to keep it until we unset it. So therefore, it's not a big issue also in a way, because once you set it, you can just keep that value. For example, if you want to set it, you keep that value 1 until you want to reset. Then you keep that value 0 until you want to set it. So there's only two operations now: set it, reset it. Once you set it, until you reset, it is set. Once you reset, until you set it, it is unset, reset. So that is the idea behind D latch. Okay, that is the idea behind D latch. So you can set it by D equal 1, then Q1 Q bar 0. You can reset it by D equal 0, then R1 S0. That means Q bar 1 Q0. Okay. Any questions? Any questions about D latch? So let's do it as a practical thing. I will use a different tab. Of course, D latch you can create straight away also, but I will build it by myself. Just one input now. And of course, you have the two NOR gates. And you need a NOT gate. U dash. Right. So this is 0. D is 0 means reset. D is 1 means set. So until you reset, it is set. Right. Until you set, it is reset. So D is 0 means reset. D is 1 means set. Okay, so that is how D latch work. It's a variation of SR latch. Okay. Question regarding the exams semester 1. If a student did not select an answer to a question, will that be considered as minus? No. If you don't mark any answer, you will get 0. Okay. No negative marks. So that is the answer for the question. Okay. Right. So any question on D latch? It's a very simple version of SR latch. Okay. Right. So we can improve the D latch again by using enable, because bit of issue is you don't have memory. Because you don't have memory, if there's a stray signal to the D input, your state change. Your state change because you have set it. There's a stray signal, make it 0. All of a sudden now it is reset. So that is the disadvantage with D latch. Okay, as long as your D is very stable, this is okay. But when there's a possibility of stray signals, this D latch is right susceptible to issues. Okay, so that is where we can make it improved version of D latch using the enable. Same concept, nothing new. Just use the two AND gates and use the enable. Right, and when enable is 0, it is memory. Right. When enable is 1, it behaves like a normal D latch. Simple as that. Okay. Right. So let's make it. Let's convert our latch into a gated D latch. So additionally, I need now two AND gates. Okay, two AND gates. Right. So this is my enable. Right. Now when enabled is 1, it just act like a normal D latch. Okay, normal D latch. That means when D is 1, Q is 1. When D is 0, Q is 0. Right? But what we can do now is we can get into the memory state by make enable disable. Now it is set state. Now if I disable it, now it does not respond to the stray signals in D. You can see it does not respond to stray signals in D. And if you want to change, you enable and then do the change and then again disable so that it doesn't respond to stray signals. Okay, so that is the idea of gated D latch. Okay, gated D latch. Right, do this exercise. Draw the Q output signal. Again, you can assume that initially it is 0. Q is 0. Okay, right. It's a D latch. It's a D latch. And one of the property of D latch is basically D latch follow the input. Okay, follow the input. So when D is 1, Q is 1. When D is 0, Q is 0. Then just keep that in mind. So we say D latch follows the input. That will make it easier for you to draw the output and faster. But that happens when enabled is enabled. When enabled is 0, it's a memory state. So therefore, you can draw it now in 30 seconds. I'll give you 1 minute. Assume that initially your output is 0 or memory is 0. Right? It's super easy. Remember D latch, D is 1 means set, D is 0 means reset. Oh, output follows input. Right? So let's assume we start with 0 and now enable is enabled. So therefore it behaves like a normal, right? Normal latch, normal D latch. So therefore when D is 1, Q is 1. Q is 1 until this point because it's enabled. Now it's why it is enabled, D is 0 means Q is 0 because D is 0 means you get 1 for here. Right, so then when D is 0, this is 0 and again D is 1 means again Q is 1 and again D is 0 means Q is 0. Remember Q follows D when it is enabled and again D goes up 1, Q goes to 1 and up to this point it remains like that. Now it is disabled. Disabled means whatever the value will remain here, it doesn't respond to the D because now it is disabled. Memory. Now it's again became enabled. Now it's again going to follow D. Already D is low, so therefore this will immediately go down. Go down and stay there. When D goes up, it goes up. When again D goes down, it goes down because now it's enabled. Again, stay like that. Now this is memory. It will stay like that until it's again enabled. When it's enabled, D is already up. So therefore it immediately goes up. And again, when D goes down, it comes down because it's enabled. That is output. So if you draw it, that means you have understood. Otherwise, again think. What I can do is help your thinking time lesser. Right? Make it your thinking time lesser so that you can spend your time more for your productive other works. So this is the output. Correct. Okay. Right. So now we have finished discussing SR latch, D latch. Our next latch is S bar bar latch or S dash R dash latch. This is also variation of SR latch, so therefore we can understand it very quickly. So the only difference is rather than no gates, we use two NAND gates. Arrangement is pretty much the same. Two NAND gates. Okay. Again, this is Q dash. Now remember earlier we called this S and this R. Okay. So another name for S is R bar. Another name for R is S bar. So this S bar and R bar is just to give it a different name. Right? Because S bar is R bar is S. Other than that, this is behaving pretty much same as your SR latch. Okay, SR latch. So therefore, just think of S bar as R bar as S. Then just think in terms of the original values. When S is 1, set. When R is 1, reset. But there's a small difference here. Earlier, when S is 0, R is 0 memory. But in S bar latch, when S and R is original terminology. When those are both 1 only now memory. Earlier, 1 was the illegal situation, invalid situation. Now, 0 is the invalid situation. So only difference is that. Okay. So now invalid situation is 0. Memory is 1. When we take S bar latch. Just consider S bar as R bar as S. So then you can easily remember that. Easily remember that. And also, now we are having two NAND gates, not two NOR gates. Okay. And again, you must be able to explain yourself how this happens. Why is S bar 0, R bar 1 is setting? Why is it 1 retain? Then 1 0 reset and 1 retain, and why 0 is invalid. Now you need to understand this using the NAND gates truth table. Earlier we used NOR gates truth table. That is the only difference. So using the NAND gates truth table, you should be able to justify yourself that this is the behavior. But justify yourself. That is how you get your confidence. That is, justification is not required for the exam, but that is required for your life, your career. If you have long-term objectives of becoming IT professional, because you carry that confidence to the industry, your life, your profession. So this is a comparison between the good old SR latch and the new S bar latch. Okay. Again, just remember R bar is your good S bar is your R. So therefore, this is setting, this is resetting. Only difference is now 1 is memory, 0 is invalid. Earlier 0 is memory, 1 is invalid. Just look at both, compare. So that is how you learn. Even artificial intelligence, AI, generative AI also learn by looking at things and seeing the similarities, dissimilarities, patterns. That is what intelligence is. Okay. So these are the 4 possibilities. Set it, reset it, remember. Remember is 1. 0 is invalid because you get both part. Okay. But yourself, you must justify yourself that this is happening. You need to take about 2 clock pulses and justify yourself that this is how it's going to be ended up. Okay. Right. So this is, remember S bar is R. R bar is S. So this means setting, set. Okay, this is set now. Q is 1 means set. Now, how do you explain this? Because that is important for your confidence. Now, this time the idea is when at least one input value is 0, regardless of the other input, the output is 1. When at least one input is 0, output is 1. Right? So therefore, now you need to start with 0 side. Because when at least one input is 0, output is 1. So therefore, this is 0, this is 1, this is 0 means this is 1. And now we can count this in the next clock cycle and say 1, 1 is 0. That 0 goes there, both 0 means 1. That comes 1 here, 1, 1 means 0. It goes like that. It keep 1, 1, 1, 0, 0. But remember, usually we don't keep it like that. We immediately make it both 1. Because we rely on 1, 1 for memory. Okay, but now you know that it sets. R bar 1, S bar 0 is set in S bar latch. Okay. Then once you get into that state, you make it both 1. Once you get into that state, you make it both 1. By the time this is 1, this is 0. When at least one input is 0, output is 1. So therefore, this is 0 means this is 1. 1, 1 means 0. At least 1 is 1 means 0, 1. Sorry, at least 1 is 0 is 1. 1, 1 means 0. So it remains. Remember memory when you make both 1. Okay. And similarly, you should be able to understand how to reset and remember. That I don't explain because I explain it for SR. Okay. And also you must justify yourself why 0, 0 is invalid. It's obvious. When you take both 0, remember when at least one input is 0, output is 1. So therefore this is 1, this is 1. And those are fed back. 0, 1 means 1. 0, 1 means 1. So it keeps remaining 1, 1. Okay. Right. So go to the logically and take 2 NAND gates, 2 bulbs, and simulate this by yourself. I'm not going to do that because I did it for the no gates, SR latch. So it's up to you to do it for the S bar latch. If you want to understand, learn it. Of course, if you're only concerned about passing exams and getting certificates, don't do that, okay? Right, so similarly, now you know the concept, right? So we can use a gate. You can make it better by a gated version, because otherwise this is responding to the stray signals. Rather, we can make it disable, okay, to make it memory. So again, when enable is 1, it behaves the normal way, normal S bar latch. But when it is 0, now it is memory. So therefore, you don't rely this memory, rather you rely this one. Okay. Okay. Right. So that is gated SR latch. You can try out this by yourself. Okay. Right. From S bar latch also, if you want, you can create a D latch because the S bar latch is behaving the same as similarly as SR latch. So just make sure you give one input after not, other input without not. Okay. So then again, when D is 0, Q is 0, D is 1, Q is 1. D output follows input. Okay. And to make it better, you can make it gated D latch as well. But gated D latch using NAND gates. Don't worry too much about the circuits. Examiners, they have not checked other than your simple SR latch. Right? So they have not checked whether you know you remember the circuits. So therefore, your task is not memorizing the circuits. Your task is understanding these latches, their differences, their usages, pros and cons, rather than memorizing these circuits. Of course, if you naturally remember, just remember, but don't spend time to memorize the circuits. Sometimes students try to do those things. They don't spend time to understand. Rather, they spend time to memorize, which is stressful, miserable thing to do. When you understand, at least you get pleasure, satisfaction that I understood complicated concept. But when you memorize something, do you get any satisfaction? I don't. I don't get any satisfaction by memorizing something I don't understand. Right. So that is the gated version of D-latch. Okay. So there are different ways we can create gated versions of D-latch. Okay. So don't worry about these circuits. This is just for your information. Okay. Not to for your exams. Okay. Fine. That's it about latches. Any questions about latches? Because we are done with latches. So we discuss SR latch, T latch, of course, the gated version of those. Then S dash R dash latch, gated version, and D latch using S dash R dash latch. But don't worry about the circuits. Just understand as a concept what is the behavior of SR latch, what is the behavior of gated SR latch, what is the behavior of D latch, what is the behavior of gated D latch, and what is the behavior of enabled signal. So when you go to the exams, that understanding is enough. But you build the confidence by analyzing these circuits. So you take not only your memory, you take your confidence. Okay. Right. So any question? Okay, so let's continue. Now we move on to the second part, that is flip-flops. Okay. Right. So here we'll look at the role of clock signal, the difference between level triggering and edge triggering of a clock. Then we'll look at what is D flip-flop, and also JK flip-flop. Actually, master slave flip-flop we don't cover, but it's in your note, but that is not something we are going to cover because it's a little bit beyond your syllabus. Okay. So therefore, we'll look at clock signal, level triggering versus edge triggering, D flip-flop, JK flip-flop, and few questions. Okay. Right. So far, our latches, we had either two inputs or one input, that is something like a simple D latch, two inputs, something like simple simple SR latch or S bar latch, or three inputs, that is enabled with SNR or S bar. Okay. Uh, from this point onwards, we will use another input, that is the clock signal. Okay. So clock signal is basically just gives 1 0 1 0 1 0 1 0 regular digital pulse, discrete pulse. Okay. So this is called the low level, high. This is the rising edge or leading edge. This is the falling edge. Again, low level, rising edge or leading edge, high, falling edge. So it keep continuing this forever as long as your computer is on. That is called clock signal. It's something like our heartbeat. It's something like heartbeat. So this clock signal has so many usages. Okay. So one usage is it help time synchronizing your digital circuit components, especially the sequential circuit components. Okay. We can use it for trigger or control sequential logic circuit components like flip-flops. And also it generates the basic potential for transmission of your pulses or data from one place to the other, like memory to the processor and so on. Okay. But we are more interested in this aspect and this aspect. Okay, especially the second aspect. So this is how you look at it. These are basically some D flip-flops. There we have used the clock signal also as an input. Of course, we have called it enable because your clock signal is also sort of playing the role of an enable. But remember, enable is something we enable, disable, but clock signal is something it always going up and down with intervals. Okay. Right. So now let's look at what are the two triggering mechanisms. You know what is trigger? Trigger means initiate something, make something happen, like trigger a gun. Okay. So there are two triggering mechanisms. Of course, triggering is done using the clock signal. That is level triggering and edge triggering. So when it comes to level triggering, we can subdivide it into high level triggering and low level triggering. Similarly, edge triggering, we can subdivide into rising edge, falling edge. Okay. So let's first concentrate on level triggering. Okay. So high level trigger means you trigger when you are in the high level of the clock cycle. So that is called high level triggering. The low level triggering means you trigger when your clock signal is in the low level. Okay. So this is high level triggering. So this is the symbol we use, high level triggering. So it's triggered when your clock signal is in the high state. Low level triggering means your circuit is triggered when the clock signal is in the low states. And the symbol is slightly different. Now it's line and circle. High level triggering, something like this. Low level triggering, something like this. So just pay attention to the symbols also. Okay. So that is low level triggering symbol. So then when it comes to edge triggering, you have the rising edge triggering or positive edge triggering, a falling edge or the negative edge triggering. So positive edge triggering means you trigger the circuit or you do some change to your circuit state during the rising edge. Not during, it's just a very tiny period. So the symbol is something like this. Okay, something like this. So this is positive edge triggering, negative edge triggering. This is positive level triggering, high level triggering, low level triggering. This is positive edge triggering, positive edge triggering. So that means circuit is triggered in this kind of a level, rising edges. Then falling edge or negative edge triggering means it's triggered when going from high to low. It's a very tiny time period. And the symbol is circle and sort of a triangle. Okay. So now you know what is high edge triggering, low edge triggering, or positive edge triggering, negative edge triggering. Then positive level triggering, negative level triggering, or high level triggering, low level triggering, positive edge triggering, negative edge triggering. So this is positive edge, this is negative edge. Okay. So the idea is reduce the time period of the triggering. That reduce the responding to the stray signals. Okay. So remember, latches are pretty much level triggered because it responds to a situation like 1, 0. Enable 1, enable 0, 4. Okay. So therefore, rather than enable signal, you can use clock signal, but it will be triggered for high level and low level, depending on your requirement. Okay, so that is called edge triggering. Okay, sorry, that is called level triggering. Okay, level triggering. Right, so this is an example. Okay, so level triggering is not very practical, but it gives you the basic confidence. Okay, basic confidence. Now this is a D latch, but rather than for the enable, we have now connected the clock signal. You can see clock. And now my enable is a clock signal. This is my D input. Now can you draw the output? Of course, output is given. Can you understand this? Okay, so this is enable is 0 or disable. That is the first part of the clock signal. So let's assume we start with Q0, so therefore it remains 0. Still enable is 0, that means it's memory. Now enable become enable because 1. By the time your D is 1, so therefore it follows D. And still it is enable, so during that time it is 1. It is 1. While it is enable, your D goes down. So that means your Q goes down. And it's still enable, but the D is 0, stays 0. Now, of course, the clock is low level, that is memory. So therefore, it doesn't respond to D. Now again, it's enable, and by the time still it is low, therefore it stay low. Now again, while clock is up high, D goes up, so therefore your Q goes up. Until this time it is up. Now my clock is low level, that is memory. So therefore whatever the value will remain there because it's memory. And again it's enable. So therefore now it is, by the time enable it is 0. So therefore it goes down until this point. Now again it goes up, but when it goes up still it's by the time it goes up, your clock has come down. So therefore it remains there. And again, by the time it enable, your D is high, it goes high. And during your positive edge, your D goes down, so therefore your Q goes down. And then it becomes disabled, so therefore it remains the memory. Okay. So that is level triggering using clock. Level triggering using clock. By the way, this is not very useful, but this is good exercise for you to understand what is level triggering using clock. Okay. So the idea is when clock is low, it is memory. When clock is high, it acts like a normal D latch. Okay. Right. So this has a problem, right? What is the problem? So it has, when this is low, yes, it doesn't respond to the stray signals. But sometimes during high edge, if there's a stray signal, actually these are 3 stray signals. If it happens during a low level, that is okay. Okay. But this stray signal is, so you can see it should have been something like this. Actually, this is a stray pulse, but it has responded to this and all of a sudden my Q has gone up. Right. So this stray signal is okay. Right. But sometimes these stray signals are affecting my output. So remember the idea about the D latch is my Q must be same as the signal. Of course, these are stray signals. So therefore, ideally my Q signal should have been something like this. Q signal should have been something like this. It shouldn't have responded to these three small pulses. But still it doesn't work. Sometimes it works for this kind of situations, right? But in some other situations, it responds to my pulses, stray pulses. So therefore, you can see that level triggering is not that good, right? Not that good. So we need to reduce the time of triggering, right? Reduce the time of triggering. Okay. So that is where we can go for the edge triggering rather than level triggering. Okay. So the idea is we have very small time pulse, and during those pulses only your circuit respond. In all the other times, your circuit is sort of a frozen. That is the idea. During these very tiny pulses only, your circuit must respond. Okay, that is why I told you edge triggering is not good enough. Sorry, level triggering is not good enough. We need to further cut down the time period for triggering. So the solution is go for edge triggering. Okay, edge triggering. So first of all, how to get this kind of edge? How to get this kind of edge in my circuit? Because we can get this kind of a thing by raw signal, raw clock signal. But what we need is not this kind of a thing, rather this kind of a thing. Okay. So this is a simplified way of doing that. Try to understand this. If someone asks how to get that kind of a sharp edge. Okay. Anyway, this is not important for your exams, but good for your confidence. Now, assume this is my input signal, this is my output signal. Okay, output signal. This is not zero output or. Now, assume C is 1. When C is 1, this is 1, right? Not 1 is 0, 1.0 is 0. Now this output is 0 when input is 1. Now assume that I change this to 0. I change this to 0. Now immediately when this is 0, this is 0. Okay. When this is 0, still this is 0 because it needs to go through a circuit. It will take a bit of time to go through the circuit. Therefore, still this is 0, still this is not 1 because earlier it was 0. But there's no circuit, no gate. Immediately when this is 0, this is 0. But when this is 0, immediately at that point, still this is 0. By the way, it doesn't matter because 0.0 is still 0. So therefore, when it goes from 1 to 0, there's no difference. Still it is 0. Okay. But after sometimes, when this is 0, this will become 1. Because after sometimes means after one pulse, when this is 0, this is 1 because now it has gone through the set and not gate. Okay, so let's start with 0 situation. This is 0, this is 0, this is 1. This is 0 because 0.1 is 0. Now, listen to me very carefully. Now, let's say all of a sudden we make it 1. All of a sudden when you make it 1, this all of a sudden this become 1 because it's just why. But all of a sudden this doesn't become 0 because it takes bit of time because this 1 need to go through this gate. So therefore there's a delay. All of a sudden when you make it 1, this is 1 because no gates. But when the moment you make it 1, still this is 1 because it takes little bit of time to go through this and become 0. During that period, you can see there's a 1 1. 1 1 means in AND gate it's 1. But that is very small period because in a flash, because this is 1, when it goes through the NOT gate, this becomes 0. 1.0 is 0. So therefore, in a flash, there's a 1, then again 0. when you change from 0 to 1. Okay, but when you change from 1 to 0, there's no change. Right? Again, when you change from 0 to 1, there's another flash, again stay there. So that is what happens. So therefore, this generate this kind of pulses, this kind of edges of ones. Okay? This kind of edges of ones. So therefore, you must understand that there's a possibility of generating that kind of very tiny pulses or edges ones. Right? But those ones are not going to stay. Those ones are just going like that and stay there. Going like that and stay there. Right? And we want to make sure that our circuit respond only at these pulses, very short period pulses. So then we say, actually what I explained you is a rising edge. Rising edge. So the result is this kind of short pulses, the periodic pulses. So this basically create rising edges. Rising edges, but not like this, just the pulses. Okay. So similarly, we can create falling edges as well. Okay, falling edges as well. But if you need falling edges, the circuit is slightly different. So this is 0 to 1 generate pulses. So when you go from 0 to 1, this kind of a circuit will generate pulses periodically. But if you use slightly different circuit, for in 1 to 0 only, it will generate pulses. Okay. Right. Look at again. Look at here. All of a sudden it become 1. And right, time to time pulses are there. So at this point there will be a pulse. And it's a very small pulse. Okay. So though we have this kind of a clock signal, when you have this kind, say this is my clock signal is the input to this circuit. So the result is the clock signal is the input. So the output is something like this, something like this. In rising edges, there's a pulse, very short period pulse. So this is how you generate. This is anyway simplified version of how to generate pulses in the rising edge. So the input is the clock signal, but output is something like this. Okay. Right. So that is just for your information. Those are not required for the exam. Those are required for your confidence, understanding. Because you must know that these things are possible, practical. Okay. Right. So now let's see, say we have a D latch. So D latch is D latch, okay? Nothing changed. But this time we are going to give this kind of a clock signal is going given to this so that this will generate pulses time to time. Pulses time to time. So therefore this is edge triggered. Because edge triggered, we have to use this symbol. Okay. So this is high level triggering. This is low level triggering. This is positive edge triggering. Edge means these edges or pulses, or you can think of like these edges, it's getting triggered. Okay, it's getting triggered. So don't worry about the circuit, okay? So just concentrate on this. Circuit is for your information. This is to generate the pulses, that these kind of pulses time to time. Because you must aware of the reality, but it doesn't mean that you must always memorize in the reality. Because you can refer to the note or any other website. Right. So now this is an exercise. This is an exercise. So this clearly shows that this is rising edge triggering D-latch, because the symbol is rising edge triggering. So that means this circuit get triggered at these points only rising edges. It's not going to respond any other places, not at the high levels or low levels, or not even at the falling edges. It's disabled in these situations. But time to time, these very short periods, your circuit is enabled. Okay, so that is why we say rising edge triggering D-latch. Right, rising edge triggering D-latch, or you can call it D flip-flop also, because now we have narrow it to very small triggering time. Right, how do you get the output? Remember, we can start saying that our Q is 0 until your triggering points, anyway, it's not going to change. Right? It's not going to change. Now it's a triggering point. By the time it is D is 1, so therefore it goes to 1. Okay. And this is against like disable. So it stays there. Until the next rising edge, it stays whatever it goes. Now this is another triggering point by the time D is 0. So that means it need to go to get back to 0, because by the time it's triggered, D is 0. That means you immediately Q must follow. And until the next rising edge, it's not going to change. It's not going to respond to these pulses. Right? Now again rising edge, by the time it is 0, so therefore it stays 0 until the next pulse. And during this pulse, you can see it's 1, so therefore it immediately goes up. Right? And until this rising edge, it's not going to change. Whatever it stays there. And during that time, during this pulse, it is 0. So therefore it immediately goes down and stays there. So therefore, this is your output. And this is your output. Now you can see that the advantage is there are some stray pulses here and there. But those pulses doesn't happen during an edge like this. So therefore, these pulses has no effect on our output. So this is another stray pulse, small stray pulse, but it doesn't happen during an edge, rising edge. It doesn't affect our output. Okay, affect our output. So likewise, try to understand. If you understand, it's beautiful thing, right? One මෝඩයි කියන්නේ තේරෙන්නේ නැහැ කියන්නේ සුන්දර දෙයක් නෙමෙයි අසුන්දර දෙයක්. සුන්දර දේ තමයි තේරුම් ගන්න. Okay. Right. So therefore, this is your output, assuming that it's a rising edge triggering D latch, or it's sort of a now D flip flop. Okay. So you can see two things now. One thing is there's a higher possibility that your output is affected by stray pulses in the input. Still, there's a small problem, that is your D goes up here, but it needs to wait until the next rising edge for our Q to follow. So therefore, it doesn't mean that the moment your D goes up, your Q goes up. No, there's a one clock cycle, maximum of one clock cycle delay. But it will happen. It will happen because in the next rising edge, it will detect it and goes there. And here it goes up here. but actually our output goes up here because that is where your next rising edge. So therefore, there will be a small delay in the output to change according to the input, but that is not a big issue because in the next rising edge anyway it will be detected. So in a way that is good because we never know that whether this is actual rising or just a stray pulse. If it is actual rising, it will stay there little bit period, and during that there will be another rising edge. But if it is a stray pulse, it will again go down by the time uh, you have your rising edge. It is already that stray pulse is done. Okay, so therefore that delay is not always bad. So that delay facilitate stray pulse ignore the stray pulse because usually stray pulse won't take more lot of time. Okay, right. So at the end of the day, what you need to understand and remember is if it is rising edge triggering, make sure you trigger only at these points only. Other places you just ignore it. That is why here it goes up, here it goes down, here it stays down because all it down, here it goes up because it's up, and here it goes down because it is down. In other places, it doesn't respond to the changes in our input. Okay, right. Any question? Any question? Of course, if you can't understand these things, don't worry too much also because you get only maximum one question or maximum two question from latches and flip-flops. So if you are good at memorizing other things, yes, still you can pass. But this is if you're serious about your profession, your personality, right? Are you a serious person who can understand complicated things, build complex things? Are you fear of complexity? So by understanding this, it doesn't make you like Einstein, but maybe a little bit serious person who can understand a little bit serious things. That builds your confidence, builds your character. I told you the one of the most complicated thing man has ever made is computer. Right? So therefore, when someone say talk about complicated things, you can say or simple things, you can say it is not computer science because computer is the most complicated device, and we try to understand those components. Okay, right, right. So this is how if you want to generate falling edges. Earlier, remember I explained you how to generate price this kind of edges during the rising edge. Now, if I want to generate this kind of pulses during the falling edge, that means this time my objective is generate these pulses here, here. Here it should be flat. So if I can generate this kind of pulses during the falling edge, right, we can call it's a falling edge triggering, not rising edge or negative edge triggering. So this circuit generate falling edge triggering. But if you produce this kind of a circuit, these are two approaches actually, two separate approaches. Both approaches will generate pulses in the falling edge. Again, this is not for the exam, this is for your confidence. Okay, this is for your confidence. Yes, of course, if there's a stray pulse in the rising edge, yes. There's nothing called perfect solutions. So the idea is make it less probable, right? There's no ideal components in this world, but we can make it more and more reliable, more and more reliable. Okay, right. So this is again not for the exam, right? But for your confidence. Okay, this part. How do you generate pulses during falling edges? Falling edges means during this kind of situations, how do you generate pulses? So you need pulses right now, like this. How to generate? So this is a simplified circuit, not realistic circuit. Falling edge means going from 1 to 0. When going from 1 to 0, there must be a pulse or spike going from 1 to 0. But when you go from 0 to 1, there should not be any spike or pulse. Okay. So let's start with 1, because when you go from 1 to 0, there should be a spike. Okay. Right. So let's say initially my value is 1. Okay. 1. So this is 1, input is 1 means this is 1. Okay. So this is 1 means this is 0 because it's a NOT gate. And this is 0 means this is another NOT gate, this is 1. Okay. This is after some saturations. So this is an AND gate, 1.1 is 1. Right? 1.1 is 1. So remember 1 becomes 0, 0 becomes 1, 1.1 is 1. Okay. That is when you saturate. Okay. So what happened if you just make it 1, say output is 0. Output is 0. Right? While output is 0, you make it immediately 1. Sorry. Now remember when output is 0, now you make immediately 0. Now this is 1. This is 1. Okay. 1 by 0, 0 by is 1, 1.1 is 1. Okay. Now you make it 1 to 0. Right. You make your input from 1 to 0. Okay. So let's assume this is 0. Okay. 1 to 0. When this is 0, how do you explain it? I'm running out of ideas. Okay. This how can we explain it? Okay. Right. So let's say my input is 1. Input is 1 means this is 0. So therefore this is 0. And when this is input is 1, this is 0. When this is 0, this is 1. So therefore 0 and 1 is 0. Right. So that is correct. Okay. Now the current situation is output is 0, input is 1. Okay. Right. So let's assume I change this to 0. Right. Change this to 0. When I change this to 0, this become 1. Right. Intermediary. Right. But still this has not affected, because still this is 1. So this is 1 means this is 1. But still it has not going through this NOT gate. It has going through the only this NOT gate. Right? Because it takes a little bit more time to go through this. But still when this is 1, this is 1. All of a sudden we have 1.1 situation. 1.1 situation means it's 1. But that is for very small period, because when this is 1 means again this becomes 0. So when this becomes 0 in after few nanoseconds, again 1.0 is 0. Therefore, it's a very small period only peak is there. Then again it goes to 0. But that happens during the transition from 1 to 0. 1 to 0. And again it settles to 0. Okay. But when you go from 0 to 1, no transition. But again, when you go from 1 to 0, again there will be a pulse. Again there will be a pulse when you go from 1 to 0. Okay. So this happens periodically when your clock cycle goes from 1 to 0. Falling edges, there will be pulses. Falling edges. Okay. So this is another way of doing this. This is one way of generating it. This is another. This is not for the exam. This is for your confidence. Okay. Okay. This is a little bit easier to understand because here you need to think about the two slime slots. The signal as your new one has going through this to this, but not going through this. But this one is easier to understand. Say now your value is, say, remember we are interested in which situation? Going from 1 to 0. Okay, 1 to 0. Now when it is 1, this is 1. When this is 1, this is 0. 1 become 0. 1 or 0 is 1. 1 by 0. So therefore this is 0 now. Right? Output is 0 when this is 1. Now we make it 0. We make it 0. Right? When we make it 0, immediately this is 0. But still it has not coming through this. During that period, it is 0, 0 is 0. Not 0 is 1. There will be a pulse. Right? Spike. But that is for very small period because after very small period, because this is 0, now it's going through this and become 1. Then 0 plus 1 is 1, 1 by 0. Therefore, this spike is for very small period only during going from 1 to 0. Going from 1 to 0. Okay. But when you go from 0 to 1, there won't be any spike. But again, when you go from 1 to 0, again there will be a spike like this. That time period is, this has become 0. So therefore, immediately this becomes 0, but still it has not going through this. So that is the situation where you get this. But in few nanoseconds, this again become 1 and again it make it 0. Okay. So therefore, there are ways to generate spikes at the falling edge as well. And if your spikes are at the falling edge, this is the symbol we use. Right? So if it is rising edge, symbol is this. If it is falling edge, symbol is this. So this means edging, the triggering is at the falling edges of the clock cycle. Falling edges of the clock cycle. This symbol says. So now you have four symbols. Positive edge, or high level edge, low level edge, rising, sorry, high level, low level, rising edge, falling edge. So this is falling edge. Rising edge is something like this. Falling edge is something like this. Okay. Four symbols. Right. So just ultimately you need to understand that these are the four possibilities. This is just for your information, saying to show that these are possible in electronic. So in the exams, they are not going to ask how to generate positive wedge spikes, how to generate negative wedge spikes, and so on. But this is for your information, your confidence. Right now, you can see the result is whenever there's a falling edge, there's a spike, very small spike, very small spike at the falling edges. And your system, your circuit is going to trigger or change its states during only these very tiny time periods only. That is during the falling edges. Okay. So then we call falling edge triggering circuit component. So your flip-flops are either rising edge triggering or falling edge triggering circuit components. So there is a difference between latch and flip-flop. Latches, either you don't have triggering or you just have the enable disable, or if it is triggering, it is either high level or low level. But that is a fairly good, that is actually 50% of the time your circuit is enabled. But here, very tiny period, your circuit is enabled. Very tiny period, not 50%, maybe just more less than 1% of the time. All the other time, your circuit is immune to stray pulses when you go for edge triggering. Okay. Right, so this is another additional thing. Now I have explained you how to generate falling edge pulses and rising edge pulses and the possibility of rising edge triggering and falling edge triggering, or positive edge triggering and negative edge triggering. So this additional concept, your latches and flip-flops can have additional two inputs called preset and clear. So far in the exam, they have not tested this, but they can. Right? Preset, clear. Okay. So the preset and clear are directly connected to your NAND gates or NOR gates. So it doesn't, it is not going through your clocks or whatever. So the idea is if you make your preset, okay, preset 1, okay, preset 1, it acts normally. For clear 1, it's normal. Okay. But if you want to make it, say, 1 here, that means you want to make Q1 without bypassing all these things, because you can see this is directly connected here. What you need to do? So if you make your clear 1, preset 1, it operates normally, because something dot 1 is same thing, right? X dot 1 is X. Okay. So therefore, when clear is 1, preset is 1, it just behaves normally. Okay. But if you want to make your Q bar 1 without considering any of these, at any time you want to instantly make Q bar 1, what you need to do is make clear 1, clear 0. Make clear 0. Because something dot 0 is 0, 0 bar is 1. Regardless of these things, right? These two inputs, something dot 0 is 0. That is for n, but this is NAND. So 0 bar is 1. So immediately, if you want to make Q bar 1 or clear, clear means Q bar 1. Clear කියන්නේ reset. Reset means Q bar 1. You just make CL, clear signal 0. If you want to make immediately Q1 or set it or preset, make preset 0. Why? 0 dot anything is 0, then 0 bar is 1, so therefore immediately this will become 1. So therefore now at any time, if you want to preset, preset means set your Q1, make your PRE 0. If at any time if you want to make it clear, clear means make Q bar 1, just make CLR equals 0. And CLR equals 0. CLR equals 0 will make this one. PRE is 0, make this one. Regardless of whatever happening here. Because this is, we are doing it at the very last moment. Okay. So therefore, when you look at latches and flip-flops, you will see, right? So you can see if you drag down these SR, D flip-flops and so on, you can see there's a preset, clear. This is the clock signal. Okay. And if you take something like JK flip-flop, you can see preset is there, clear is there. If preset is 0, immediately Q is 0, Q is 1. If clear is 0, immediately Q dash is 1. So that is a way of making preset or clear. Preset means make Q1, clear means make Q dash 1, bypassing anything. Okay, so that is something you need to understand, because those are standard components of your flip-flops. Right? For example, if you take a D flip-flop, always you have the preset and clear other than your other signals. Okay. other input and output. So therefore, preset and clear are another two inputs which can immediately make your Q1. That is when you make preset 0. If you want to make immediately your Q-1, make sure your clear is 0. You don't care what are the other what are happening in other inputs. Just this will do it. Just this will do it because you are just those are just connected to those NAND gates. Okay, NAND gates. Right? Is it clear? Okay. So when preset is 0, you set the Q to 1. When clear is 0, you set the Q dash to 1. When both clear and preset are 1, that is normal working behavior. But don't make both clear and preset 0. දෙකම 0 කරන්න යන්න එපා. දෙකම 0 කරාම වෙන වැඩේව දන්නවනේ. So when you make both 0, both your Q and Q dash become 1. That is invalid. So therefore, don't do that. Okay. Don't do that because it doesn't make sense. So this is the invalid scenario. Right. So that's it about preset and clear. So any latch can have preset and clear. Okay. Especially if your latch get into invalid situations, that is how you reset those things. Okay. Right. So remember I told you that when we change input, your output doesn't change immediately. There's a delay. So the idea behind D latch or D flip flop is your output follows input. Say this is my input. Ideally, my output must follow input. Something like this. Output must follow it. But in reality, there can be a delay. Why? If it is edge triggering, you need to wait until the edge. During the edge only, it will be detected. It will be detected that it has come down. Okay. Even in level triggering also, there's a delay. Right? Level triggering also, there's a delay. Edge triggering also, there's a delay. So therefore, there's a delay in your D flip-flops or whatever flip-flop, there's a small delay. Okay. Sometimes that is good because that delay help you ignore the stray pulses. Ignore the stray pulses. So therefore, it's not a bad thing, but you must know that there is a possibility of a delay. Okay. Is it clear? Right. So this explain that D flip-flop as a delay flip-flop. Okay. Let's assume this is positive edge triggering. So that means it will trigger only at these places. Now, assume our Q is initially 0. Now only it responds to our D. Now it detects that D is high, it goes high. Now until this point, it stays there because it's not going to respond to any other places. In the next edge, again it finds that it is high. So therefore it stays there until the next moment. During this spike, rising edge, it detects that, okay, D is low, it goes down. Right? So now you can see actually, now we have an issue also. There was a high situation here, but we did not detect that. We did not detect that because by the time the next high, it has gone down, gone up, and again gone down. So therefore, it stays in the up situation. Actually, when your data signal has gone down, but we never detected this because before the next rising edge, it has again come up. Actually, there was a pulse also. Right? So therefore, this can be lead to some errors. lead to some errors. Of course, not responding to these spikes are good, but now your data signal is 1 0 0 1, but my output signal is 1 1 1 1. Okay, so there are some practical problems. Okay, practical problems. Right. So this is a past paper question. So these questions are not easy, right? So that is, so you might be wondering, this guy is doing crazy things, right? Of course, without doing these crazy, complicated things, you will not be able to do this past paper. Or you can decide, okay, I don't need these answer marks. Okay, that is your decision. But engineers, they don't give up. They don't run away from challenges. They face it. So if you have that kind of attitude, learn these things and try to do these kind of questions. If not in the exams, at least when you have leisure time. Right. So can you read this question? And most probably you will not be able to do this, but at least give a try. I can give you 3 minutes. At least try to understand. So take 3 minutes and see whether you can get the answer. Is it A, B, C, D, or E? So this question, just check whether you know what is a D flip-flop and related concepts. It doesn't check whether you know this circuit, that circuit, the internal circuit of a D. No, we just check whether you know what is a D flip, what is a flip-flop is, what is edge triggering is. That's it. So I'll give you a small hint. It says starting state at the first clock pulse is 0 0. So that means you can start it like this. Q0 is 0, Q1 is 0. This is your starting point. So now you can assume that this 0 is fed it here, this 0 is fed it here, 0 or 0 is 0, not 0 is 1, therefore this is 1. From that point onwards, you think for the next clock pulse. So this is what is the next output. Then for the next output, next clock pulse, next clock pulse, next clock pulse, what happens? So this is you start, because it says at starting point, take it as Q0 is 0, Q1 is 0. When it going through a gate circuit component, it will take one pulse, but it won't take time to go through this kind of a thing. But going through a circuit component like that, it will take one clock cycle. That is what this clock cycle is. Actually, this clock is synchronizing the circuit. Right? It's synchronizing the circuit because it's going to respond only those edges. So this is basically positive edge triggering. Right? It's synchronized. So synchronization is good. Otherwise, it results in unpredictable situations. But remember, this is not connected to a clock. So therefore, when 0, 0, immediately it will become 0 plus 0 is 0, 0, not 0 is 1. So when these two are 0, immediately this is 1. There's no delay here, but there's a delay here. That is why we say D flip-flop as a delay flip-flop of one clock cycle. Right, so I gave you enough hints. Then think about what is the output for the next clock cycle. Because you know how the D flip-flop work. Output follow input. When D is 0, your Q is 0. When D is 1, your Q is 1 for the next clock cycle. Your output follows input, but after one clock cycle. Okay. So it's not an easy question anyway. Okay. It's not an easy question. Anyone got the answer? Right. So you need to go through the cycles. Right. You need to work through that. Okay. So this is how you do it. You can start with the given information because the given information says Q0 is 0, Q1 is 0. Q0 is 0, Q1 is 0. So therefore, Q0 is 0. This is Q0 is 0, Q1 is 0. Okay. So therefore, now you can see that this is 0, this is 0. Okay, let me take the black color. Right. So Q0 is 0, Q1 is 0. So therefore, this is 0, this is 0. 0 plus 0 is 0. Not 0 is 1. So therefore, this is 1. This is 1 now. Okay. Remember, this is a D flip flop. D flip flop. So therefore, what happens in the next clock pulse? This 1 comes here because output follows input. Right? Output follows input. And this 0 comes here because earlier this is 0. In one clock cycle, this one can't go to this place. So this is operating on the previous input. This is operating on the previous input. So therefore, this one follows here and this 0 follows here in the next clock pulse. So therefore, next clock pulse output is 1 0. 1 0. Okay. Earlier, of course, 0 0. That is given. Now it is 1 0. Now that 0 goes there. This one goes there. 1 plus 0 is 1. 1 by 0. So therefore now this is 0. This is 0. That happens immediately in the output. Now this 0 comes here. That is during the next clock pulse. This one goes there. That is why we call it delay flip-flops. So that means 0 1. 0 1. Now immediately this happens. Right? 0 1. Now it's 0 1. So this is 0. This is 1. 0 plus 1 is 1. 1 by 0. So therefore, this is 0. Now during the next clock pulse, because there will be a triggering, this 0 comes here. And this 0 goes there. So therefore, the next output is 0 0. Now immediately when the next output is 0, these zeros are fed it here. 0 0 is 0. 0 by is 1. And that one comes here. Now during the next triggering, this one comes here. This 0 goes there. So therefore output is 1 0. And immediately this is 1, this is 0. 1 plus 0 is 1. 1 by 0. So therefore this is 0. But anyway, that's it because other values they have not asked. Of course, you can keep telling. Keep telling. Right. So the idea is if the clock is connected, these components are time synchronized. But no clock pins, when there's output, immediately it goes to the next point. Okay. Therefore, you must keep track of what is here will be here in the next clock cycle. What is here is the output for this one. But those things are synchronized. Both will happen at the same time. They both edge triggered. Both will happen. Both these flip-flops or D flip-flops will respond to the maybe same rising edge because same clock cycle is connected. Sometimes they will say this is responding to the rising edge, this is responding to the falling edge. So then things are even complicated. Okay. I know that is not easy question, not at all easy question, but of course, if you want to do those questions, forget about the exams. So this session is not targeting exams. This session is targeting your confidence, right? Confidence. Because I told you what you carry to your interviews, jobs, life, career is confidence, not your certificates. Certificate will give you an interview in the private sector. Nothing beyond that. Nothing beyond that. It doesn't mean that දැන් කාටද හිතෙන්න පුළුවන් එහෙම නම් දැන් බුදුහාමෝ මට මේක තේරුන්නේ නැහැ මට ජීවිතයක් නැහැ කියලා. ඔය හැමෝම software developers ලා වෙන්න ඕනෙත් නැහැ. හැමෝම electronic digital circuit designers ලා වෙන්න ඕනෙත් නැහැනේ. So if you don't understand this, maybe you can later understand after some times. Okay, මේක තේරුන්නේ නැහැ කියලා software engineer කෙනෙක් නොවී ඉන්න ඕනේ නැහැ. And in general, if you don't understand these things, maybe you can become a QA engineer. Maybe you can become a UI engineer. So there are plenty of opportunities. Business analyst. Maybe you are good at understanding business related things. Understanding user requirements. So therefore, you find out what are your strengths. But maybe you are good enough to understand complicated logic, face challenges, and become a software engineer, data scientist, right? AI engineer, or even digital electronic engineer one day. Because this is not the end of your life, right? You will be doing your MScs, MA, and blah, blah, blah. Right. So now we move on to JK latch. Actually, it's not JK latch. Now we move on to JK latch and JK flip-flop. That is our last topic. Okay. This is our last topic. Right. So this is easy. Understanding JK latch and JK flip-flop. Okay. Now JK flip-flop is or JK latch is because still we have not connected the clock signal. As long as clock signal is not there, it's a latch. Okay, it's a latch. So the behavior of JK latch is 100%, not 100%, 90% same as SR latch. So therefore, simply you can replace J with S, K with R. Actually, JK stands for Jack Kilby. So those are the two guys who came up with this particular component, JK latch. And then everyone found that JK latch is better than SR latch. Okay, so therefore JK latch has become sort of a standard latch in day-to-day use. Of course, we learn SR latch because SR latch is easier to understand. So the behavior is 90% same. So therefore, you can simply replace J with S, K with R. So then you can see that K1 means reset because K means R. K1 J0 means reset. Then J1 K0, that means S1 R0 means set. And again, 0 means, remember in SR latch also 0 is memory. That is memory. Only difference is in SR latch, 1 is an invalid scenario because remember we got both one. But when you arrange your system, remember this is not SR latch. You can see this output is connected to here. This output is connected to here. So therefore, this is not SR latch or gated SR latch. This is JK latch. And when you arrange like this, there's advantage that is 1, 1 is no longer an invalid scenario. 1, 1 will invert the value. If earlier it is 1, 0, when you take 1, 1, now it becomes 0, 1. If earlier 0, 1, now it will become 1, 0. So therefore, now 1, 1 is not invalid scenario, rather 1, 1 is inversion. Whatever the current value is inverted. Current value 0 will become 1. If current value is 1, it will become 0. Okay. So that is how JK latch work. Again, no need to memorize this circuit. Just remember JK latch as another latch. You have J, K, Q, Q dash. And you can always think J as S, K as R. Only exception is now J1, R1 is not invalid. J1, R1 will invert the value. QT plus 1 is QT bar. So memory is QT plus 1 is QT. Ilang clocks time එක කලින් එකමයි. That is memory, but this invert. Okay. Right, so that is called JK latch. This is JK latch using NOR gate. JK latch also can be built using NAND gates also. So this is the simplest JK latch using NOR gates. Again, examiners are not worried about the circuits. They are more worried about, do you know the behavior of SR latch, S bar, bar latch, D latch, gated D latch, JK latch. Okay. So this is set and remember. Okay. That is just for your information. Don't worry too much about that. And similarly, you can reset and remember. So remember, J is like S, K is like R. So reset and remember. Okay. So this is also sort of an invalid situation, but that invalid situation is slightly different scenario because it's invert. If it is 0, it becomes 1. If it is 1, it becomes 0. Okay. When you go for J equal 1, K equal 1. Sometimes we call it racing situation because it's when you give 1, 1 situation things, your output keep changing. Output 0, 1, 0, 1, 0, 1 like that. So that we call it racing situation. But cleverly, we can use this for some advantages. So that is why I did not make it call it a invalid situation, rather inversion or racing situation. Because in some applications, we can use it for our advantage. Okay. But in general, yes, this is also invalid situation because this keep changing your current value. Right? 0 become 1, then 1 becomes 0, then 0 become 1, and 1 becomes 0, and so on. Okay. So when you have time, you can build this kind of arrangement in logically and see what happens when 1, 1. If you are curious enough. Okay, if you are a critical thinker. If you are curious enough, if you want to see what happens, and if you want to build your own circuits in the future, because the world need that kind of people. කාලා බීලා පින්ගුත්තරේ වගේ ඉන්න අයට අමතරව අලුත් දේවල් හදන අයත් ලෝකෙට ඕන. ඉංජිනේරුවෝ, විද්‍යාඥයෝ, වෛද්‍යවරුත් ඕන අපිට. හැමෝම නිකන් පින්ගුත්තරේ වගේ හිටියොත් එහෙම වැඩක් නැහැ. Right, so this is JK latch using NOR gates. Similarly, if you want, you can create a JK latch using NAND gates. Okay. The behavior is the same, just the two different circuits. Okay. So this is again set and remember, reset and remember. Okay. So same behavior, just two possible circuits. Right. So this oscillator, your racing situation is not very practical because it keeps changing, right? 1 becomes 0, then 0 become 1, then 1 becomes 0, 0 become 1. So we can prevent that if you use JK latch with clock signal, that means you need to go for JK flip-flop. Okay, JK flip-flop. Again, don't worry too much about the circuit. Your task is understand what is happening. Okay. Right. So this is level triggered JK flip-flop. Remember the level triggering is not going to fix your problems fully. Maybe partial solution. Okay, partial solution, because that time period is too much. Ideally, what we need is edge triggering, positive edge or negative edge. But anyway, this is an example for level triggering. You can see this doesn't have this symbol. This symbol means edge triggering, but this is basically high level triggering. High level triggering. If it is low level, something like 0 is there. This is high level triggered JK latch or JK flip flop, because when you have the clock, it's usually called flip flop. Okay. But when we have level triggering, sometimes we still call it latch. So it's become real flip flop when you go for edge triggering, positive edge or negative edge. Okay. Right. So can you understand the output? Anyway, output is already there. Can you understand why the output is getting like this? Or can you draw the output? Forget about this, and can you draw the output by yourself? Okay. So it's very easy, right? Because it's same as SR latch. Only thing is, it's going to respond when your clock signal is enabled. Assume that this is positive edge, positive level, high level triggering. Other times it is not going to respond to the events. Okay. Right. So this one has started with 1. Of course, you could have started with 0 also. Okay. Right. So this is the first time it become really enabled. So by the time, remember, J is S, K is R. Okay. So therefore, by the time your clock enable, your R is 1, S is 0. Or in other words, K is 1, J is 0. So R is 1 means reset. So therefore, immediately it goes to 0. And during this time period, there's no change to the L and K. So therefore, it stays like that. And of course, this is the disabled time period. That time period, anyway, nothing is going to change. So it stays there. Now again, it goes to the high side. By the time both S and R or J and K are 0, that is memory. So during that period, nothing changed. Right. Now it's again back to the disabled time period. So it stays there. By the time it goes to the high side again, your J is 1, R is 0, or S is 1, J is 1, K is 0, or S is 1, R is 0. Therefore, it's set. During this period, no change. So therefore, until this time, it stays there in the memory. Now again, it goes up. By the time again S is 1, S means J, it's set. It is set. And then it goes to 0, but that is memory. So therefore, it stays there. And though it goes down, it is memory now. Stay there. Now, until this time, nothing changed. That is memory. By this time, both are 1. Now we are in trouble. Why? By the time the clock is in the high level, now both S and R or J and K are 1. That is a racing situation. So racing situation means it goes down, goes up, goes up, down, goes up. Okay. So during that period, it will go like this. Racing situation. Okay. But after some times again, J becomes 0, OS becomes 0, then it is reset. So therefore, from this point again, it is reset. then of course it is sort of a disable. Again, by the time it goes to the high edge, again both are 1. So that means again tracing situation. And again it goes to the memory. And again when it's high, again both are 1, again racing situation, and so on. So you can see there's a possibility of racing situations in edge trigger in high level, low level triggering. So these are not good things. So that actually shows you the issue with level triggering. Level triggering. Okay. No, still that out delay is there, because anyway these things that you need to wait until triggering. So delay is still there. Okay, delay is still there. Okay, right. So the other thing is if you go for edge level triggering, these additional issues are also there. Okay, these additional issues are also there. Okay, so that's something you need to remember. Right. So therefore, solution is not the level triggering, but if you get a question like this, you should be able to write the output. Okay. So the real solution is not going for the level triggering. This is just for your information that level triggering can still getting into the race situations. So therefore, ideally, you should go for edge triggering, right? Positive edge triggering or negative edge triggering, rising edge or falling edge, right? Because then the triggering time is very small, so that reduce the possibility of responding to stray signals, stray pulses. It doesn't 100% eliminate, but it make it better. Right. So now, can you draw this? Of course, the output is given, but can you verify that? Right. So this is again J is something like S, K is something like R. Right. Let's assume we start with high side. Until this pulse, nothing will change. Nothing will change. And then comes this pulse. By this pulse, J is 0, R is, K is 1, that is something like S is 0, R is 1, that is reset. So it's immediately reset. And until this pulse, you don't need to worry at all. And during this pulse, both are 0, that means memory. So therefore, until this pulse, it stays memory. And during this, our J is 1, K is 0, or S is 1, R is 0, that means set. So until this pulse, it doesn't change. And during this pulse, again, J is 1, R is 0, or S is 1, R is 0. Therefore, it stays there until this point. And during this pulse, your J, that is S is 1, R is 1. Right? You can see S is 1, R is 1. Okay. So that is invalid, right? Look at this one. Yeah, S is 1, R is 1. So then what happens? Inversion. Remember, S is 1, R is 1 means inversion, but it doesn't lead to a racing situation because then the pulse is over. Right? So therefore, immediately goes down because S is 1 or J is 1, K is 1. And then until the next pulse, it stays there. In the next pulse, again both are 1, J and K 1, that is inversion. Again it goes to 1. Until the next pulse, it stays there. And again both are 1, so it goes down. So you can see it's not a racing situation. Now it is inversion. Maybe inversion is something you want to do. Right? Sometimes you want to change your 1 to 0, 0 to 1. Okay. So now you don't get into the racing situations, rather it's smoothly working, and you can do additional thing called inversion also by giving J and K both 1. So that is how JK flip-flop work under edge triggering. edge triggering. It can be positive edge, negative edge. We don't care whether it's positive edge or negative edge. What we care is when do we have that triggering. Right? Don't think that the positive edge and negative edge behave differently. Uh, Edge is edge. Okay, edge is edge. Right. Any questions? Okay. So this is positive edge triggering. JK, Q and Q dash. This is JK flip-flop. Positive edge triggering JK flip-flop. Of course, the output is not going to change. But now 1-1 is toggling. It's not a race situation, right? It's not a race situation. It's a toggle. Toggle is not a bad thing. Toggle means 1 becomes 0. If already 0, 0 become 1. Okay. Toggle is not oscillating or racing. Racing is bad. Oscillating is bad. But toggle is, maybe we can use it as another functionality. Again, don't worry about the circuit, just because your questions will be using these kind of uh, symbols, okay? Right. So you can do a demonstration by, rather than JK flip-flop, you make your own one. You can even make this kind of a thing. For example, let's say we can edit, because the ready-made JK flip-flops you can use. Logically, do we have a JK flip-flop? Yes, JK flip-flop is there. Okay. Then you need to add a clock also. Yes, clock is there. So you need toggles, switches. Bulbs. You need to set preset and clear. So remember how the preset and clear work. When preset is 0, preset. So therefore make both 1. Then it's going to work in the normal way. The normal way. Right? So now this is my J and K. Okay? J and K. Let's have the label for J and K. J, K. So remember J is S, K is R. Or you can say J, or you can say it is your set. K, or you can just think of it as R. This is of course the Q and Q bar. Q dash. Right. Now this is in the reset situation. Okay. Now if I want to set what I want to do, of course both are enabled. Okay. So I just need to say S1. But it is not going to immediately do this. It is going to do this in the clock pulse only. Okay. Look at this. Now you can see, right, now it's back to the memory, right? So I can change the clock pulse rate. Okay. Let's see whether I can change the clock pulse rate. Pulse rate. Yes. So I can make it low, small. I'll make it 5,000 so that we can see it better. Can I make it a bit better? I make it something else. Say 2,000. Right, now I make it slower so that you can see. Now I will reset. How to reset? Make this one, but it will not immediately reset. It will reset with the clock pulse. Okay. Right, now I reset. Still it is not there. On now only it reset. Right, now I will make it back to memory. Now I will set it, but it will not immediately happen. It will happen in the clock pulse. Right, now I set it, but now it is time synchronized. So the responses happens during the clock cycle, clock edges only, clock edges only. That is why we say clock synchronize, just like a band master or orchestra master, it synchronizes things also. Now what happens if both are one? Both are one. That means what? Both are one means invert. Okay, but it happened in the clock's pulse. Right now it should invert. You can see invert. Right? But of course now every clock pulse it is getting invert now. Okay. So therefore make sure you invert and put it back to both zero. Okay. Put it back to both zero. At any time, if you want to preset, you can. How to preset? Oh, sorry. How now it is already preset. If I want to clear, that means make q dash 0, so q dash 1 immediately. This doesn't need the clock pulse. This will happen immediately. Right? Look at immediately it happens. Immediately it happens. Okay. So this one also it is because this preset and clear does not depends on the clock pulse. Immediately it happens. Okay, immediately it happens. Of course, this is the invalid situation. Right? This is the invalid situation. Both are zero. So this is invalid situation. So don't do like that. So this is the normal running condition. Both preset and clear are one. So now it is behaving like a normal JK flip flop. Right. Any question? Okay. Right. If you don't have any question, do this question. 2021 question 12. So this hint is not given in the exam. I added this hint because most of the time you forget, you will not see it. Read the hint also, but it is not in the exam paper. It's a very easy question anyway. Okay, right. So it's a JK flip flop. Clock is there. Therefore, it's a flip flop definitely, and it's a edge triggering, not level triggering. Which of the following is are considered as the toggle conditions? Toggle conditions. Toggle condition means toggle the value. For a logic circuit arrangement with a JK flip-flop as shown in the figure. So this hint is given to you by me. Note is the NOT gate at the enable signal. Okay. So that means when enabled is 1, this is 0. When this is 0, because this AND gate, both are 0. Right? Both are 0 means memory. Both are 0 means memory. So memory is not the one that you want, right? Because toggle is both are 1. Toggle is both are 1. So how do you get both are 1? If enable is 0, 0 dot something is, sorry, enable is 0 means this is 1. 1 dot something is the same thing. So that means when this is 0, this is x, because x dot 1 is x, y dot 1 is y. So now you want to make both 1. How to make both 1? Make x 1, y 1. Because 1 dot 1 is 1, 1 dot 1 is 1. Make this 0, because not 0 is 1. So then you get 1, 1. 1, 1 is the toggle situation. So if you want to get the toggle situation, you need to make sure that enable is 0. Right? Enable is 0. X is 1, y is 1. Answer is, anyone got D? Yes, answer is D. Okay. Answer is D. So you must have really sharp thinking to do these kind of questions, okay? Because this is basically digital electronic engineering. So you must have that attitude of engineer to do these kind of questions. Of course, not every question is like that. Okay. Right. So this is also 2020 question 39. Give it a try. So when I say give it a try, at least give it a try, okay? Don't worry if you can't get the correct answer, but give it a try. Maybe you can do it. And remember, initially cleared means 0. It says initially cleared. Cleared means this is 0. This is 0, this is 1. Sorry, clear means yes, this is 0, this is 1. Preset clear. Initially cleared. And you need to think 6 clock pulses. 6 clock pulses. 6 clock pulses sequence. Clock is not shown, but you need to, clock is shown. Clock is shown. It looks like edge level triggering. And J is Q bar. Your J is Q bar. You can see Q bar is connected to J. And your K is hard coded to 1. K is always 1. It is not going to change. But J is Q bar. Now think. You need to think 6 clock pulses and Q. What is the next Q, next Q, next Q? Your question is, what is next Q, next Q, next Q? Okay. Initially, you can assume it is 0. That is what is meant by cleared. Preset means 1. Q is 1. Clear means Q is 0. Q bar is 1. It's super easy question, right? Anyway, if you know in general how the JK flip-flop work. Right? Anyone got the answer? Don't worry, you can make mistakes, but give it a try. Now this one will be the input to the next clock cycle. So this 0 is not going to affect anything because it's output. It's not connected. Right? So initially, let's say 0. Now it is 1, 1 situation. So therefore, next output 1, 1 means inversion. Q become 0 become 1, 1 become 0. Therefore, for the next clock cycle, this will be 1, this will be 0. So I'm interested in this output. Okay. Now this 0 will fed it to this, because this one is the one that fed it to here. So remember, J is like S, K is like R, SR. This is always 1. So this is like set. Right? Sorry, reset. Because it's like R1, S0. Okay. So it's like reset. So it's something like 0. Okay. Something like 0. So therefore now it's reset. So that means this is 0, this is 1. And this one is fed it here. Now again 1, 1. It's toggle. Toggle means this is 1, this is 0. Okay. And this 0 is fed it here. 0, 1. It is again reset. Okay. Reset. Reset means this is 1, this is 0. And this one is fed it here. Again 1, 1. Because this is always 1. Okay. Toggle. That means this is 0, this is 1. So therefore this keep changing. 0, 1, 0, 1, 0, 1. So whatever the answer is should be keep changing 1. So these are not keep changing. Not keep changing. But this one is keep changing. 0, 1, 0, 1, 0, 1. Okay. So answer should be C. Answer should be C. Because it keep getting into 1, then toggle, 0, then reset. Toggle, reset, toggle, reset. Okay. Right. So this is a gentle comparison between latch and flip-flop. Latch, no need of a clock signal, but you can have enable. But flip-flop, you have a clock signal. So made of simple logic gates, made of pair of latches. Okay. Latch serve as memory elements in synchronous sequence circuits. Flip-flop even, sorry, asynchronous setup, but flip-flops are synchronized, time synchronized. Because it change at that particular edges only. Latches are pretty much like level edging. Okay, level triggering, not level edging, level triggered. Or you simply use enable because enable is level, right? Not edge. But flip-flops are edge triggering, rising edge or falling edge. Okay. So latches susceptible to noise, stray pulses, but flip-flop more stable. We can't say perfect, but more reliable. Okay, so these are some examples. Okay. So this is another example where you have the clock pulse and it's edge triggering, positive edge triggering. And this is my J, this is my K. And also we have the set and reset also. Sometimes we set it, sometimes we reset it. Okay. Right. So you need to do it by yourself. Okay. You need to do it by yourself. The answers are given. Okay. So master slave D flip-flops, I'm not going to do it. But if you're curious enough, I have given you some insight of those things. And also I have given you the references so that if you're interested further, you can go and have a look at it, right? But don't spend too much of time because your exams are nearing, okay? Right, so there are a few more past paper questions you can try out. Some of the questions are very difficult. Actually, one of the question I can't find the answer. Maybe the answer is wrong or whatever, okay? Right, so that's it. So you have the afternoon session. We will start it at 2, okay? and we'll have a programming. And so that is afternoon session. I will send you separate invitation for that. Okay, Zoom invitation for that. Right? So that will be at 2. We'll stop at this point. Any questions? Like if you have any questions, you can ask in the afternoon session also. Okay, but afternoon session is not for the batch 1 because we have done that programming part, but for the others. Okay, right. We'll stop at this point.